So the first way we're going to graph our quadratic function is what's called in this book using the standard form. I've also seen it called the vertex form. And the equation that you're interested in is this equation right here. If it is in this form right here, that's what the book calls the standard form, or like I said, the vertex form. And this is a quadratic function. Notice that my variable x, which is here, is raised to the highest power of 2. So that indicates it's quadratic in nature. I still have a leading coefficient a, which is going to help me determine whether or not my function faces up or down. And then the other thing about this formula is this h k. That is the unique part that puts it into this form. And what h and k tell me is the ordered pair for the vertex of the parabola that I'm going to graph. Now notice that the sign of h, when I put it in the ordered pair, is opposite from what it is in the formula. And the sign for k in the ordered pair is the same as in the formula. So you want to watch out for that whenever you're graphing, but we're going to go ahead and work an example together. So here I want to graph the quadratic function 2 times x plus 2 quantity squared minus 1. And I'm going to go through a series of steps here and as we kind of break it down. The first thing you want to look at when graphing this function is whether or not the function opens up or down, and that comes from the leading coefficient 2. So since 2 is positive, I know that this function opens up. And while we're talking about this, I realize that you can put this function in your graphing calculator or in Desmos and get a picture of it. But if we don't have that, or if I want to know what the characteristics of this function are, these are the steps we're going to go through and follow. Okay, so now that I know the function opens up, I want to determine, well, what's the vertex of my function? Again, that comes from the hk, or in other words, it comes from this value and this value. I'll circle that. These two numbers here. So when I write the ordered pair for the vertex, the sign on h is opposite in what it is in my formula. So if this is a positive 2 here, then it's actually a negative 2 in my ordered pair. The k keeps its same sign, so a negative 1 is just a negative 1. So this is the ordered pair, or the point that is the vertex in my formula. The next thing I want to look at is I want to find the x and the y intercepts if they exist for this function. So we're going to start with the x-intercept. To find the x-intercept, we're going to set the function equal to 0 and then solve for x, because remember, that gives me the places, those are the roots, those are the solutions, and that's where it crosses the x-axis then. So when I solve this equation, we're going to come down here and we say 2 times x plus 2 squared minus 1 equals 0. To solve this equation, we add 1 to the right-hand side. So this is 2 times x plus 2 squared equals 1. I'm going to divide both sides by 2, and I get x plus 2 squared is 1/2. Now that I have it into a squared term equal to 1/2, I can apply the square root property and take the square root of both sides. That gives me x plus 2 equals plus or minus the square root of 1/2. Now ultimately I'm trying to solve for x, so I'm going to subtract 2 to both sides and and combine that with plus or minus the square root of 1/2. This is the exact answer of the two roots, or the two places where it's going to cross the x-axis. Now quite honestly, I can't graph that number on my axis unless I turn it into a decimal representation. Okay, which we will do in a minute, but this is the exact answer of where it crosses the x-axis. Now, the next thing I'm looking for are the y-intercepts. Okay, so that's when we let x be equal to 0 in the equation and we solve from there. So remember, my equation is given up here. So I'm going to have y equals 2 times, and I'm going to replace x with 0, so 0 plus 2 squared minus 1. So 0 plus 2 is 2. Squared would be 4, and 4 times 2 is 8. So 8 minus 1 is equal to 7. So in other words, this crosses the y-axis at the point 0, 7. Okay, now the last thing we're going to do when we graph this is, if it's necessary, I will go ahead and use the axis of symmetry to be able to put points on both sides of my vertex. And we don't end up needing that in this example, but we might in a little while. So I have everything I need to be able to graph this, and let's go ahead and apply that. I'm going to come over here, I'm going to draw me an x and y axis, and I know from what I solved, we'll scroll back over here, I know that I have a vertex here at -2, -1. Okay, so I need to put the point -2, -1 on my graph over here. So I'm going to move -2 in the x direction and -1 in the y direction. Here is that point. Now remember that we also know that we're going, and by the way, this is going to go face up, right? So I'm going to be crossing the x-axis, and we know that because we solved it over here. But I don't know where to put those numbers on the x coordinate system because I can't, I don't know what this number is. So I'm going to do -2 plus the square root of 1/2 in my calculator, and I'm going to pull that up, and we'll do that real fast. So on my calculator, I have taken -2 plus the square root of 1/2 and found the decimal value, and -2 minus the square root of 1/2 and found the decimal value. So these are the two places approximately that it's going to cross the x-axis, and I'm going to plot them on my graph right now. So if I come over here, I know that I am at somewhere around -2.7, so that'd be kind of like right here, and that's -2.7, and then I'm at, over here I'm at somewhere like 1.2, and I didn't draw it to scale very well, but that red dot indicates we'll call it -1.3. Now the other point that I solved for was the y-intercept, which means that we're crossing the y-axis over here at 7. So I'm just going to come up here, and we'll just call this 7 at the top, and I know that I am crossing the graph right here. So when I sketch this, these are the only 4 points that technically I need to have to be able to sketch it. Now, because I know that my quadratic or parabola is symmetric along the axis of symmetry, which passes directly through that vertex, if I wanted to reflect this point 7 over here to the other side to get maybe a better picture, I could have done that to be able to draw it. And that's what the axis of symmetry can get me if I need another point to be able to draw. So these are the steps that you're going to go through and you're going to use when you are graphing a quadratic function given the standard or vertex form. These 4 steps right here.